Greetings everyone, welcome to today's video. I'm Clifford Mwenda, GMAT of the International Scholars Program, the Quant areas, and for today we'll be dealing with cyclicity. Previously we did cyclicity and we covered some areas and did some questions in problem solving or quantitative reasoning section. For today we'll be dealing or working data sufficiency questions, actually 3 data sufficiency questions, and see how cyclicity comes to play in data insight section. And so without much further ado, let's jump into the video. Okay, so we say that cyclicity is often used in remainders and exponents questions, and it's more like repetitions of numbers when you have the exponents. For instance, cyclicities of numbers 0 to 9, we have 0, 1, 5, and 6 having a cyclicity of 1. That is, if you take the likes of 5 squared, or 5 to the power 1, that's 5. 5 to the power 2, that's 25. 5 to the power 3, I believe that's 125. As you can see, the last digit is always 5, so cyclicity of 1. If we go to 4, which 4 and 9 has a cyclicity or have a cyclicity of 2. So 4 squared, 4 to the power 1, that's 4. 4 squared, that's 16. 4 to the power 4, believe that should be 10. Plus 6 times 4, that's 40. The last digit should also end in 4. Not 4 to the power 3, but 4 to the power 3. Not 4 to the power 4, but 4 to the power 3. 4 to the power 4, then should end in 6. So cyclicity of 2, cycles of 2. If you go to the likes of 2, 3, 7, and 8, we have cyclicity of 4. You can go ahead and try maybe 2. 2 to the power 1, 2. 2 squared, that's 4. 2 to the power 3, that's 8. 2 to the power 4, 16. 2 to the power 5 times 2, that's 32, ends in 2. As you can see, 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6, cycles of 4. So that's basically it in terms of introduction. I'll just show the questions, and for those who are not familiar with the answer choices, you can go ahead, pause the video right now, give the question a try, and then I'll jump in. But if you find you're good with the answer choices, I'll be sharing on the screen that we'll be using to work out without the answer choices. You can go ahead and pause then. So I'll write down my answer choices: 12, 10, A, B, C, D, E. So you asked, if X is a positive integer, is the remainder 0 when 3 to the power X plus 1 is divided by 10? So what that does mean? What does that even mean? Is the remainder 0 when 3 to the power X plus 1 is divided by 10? First of all, this is a yes, no question. So let's define sufficiency if you have an absolute yes or absolute no. And when you say, is the remainder 0 when 3 to the power X plus 1 is divided by 10, that means, let's say, 3 to the power X. How many cycles does it have? Or the cyclicity of 3 is, we say is 4. Let's give it a try. So 3 to the power 1, that should be 3. 3 squared, 9. 3 to the power 3, that should be 27. 3 to the power 4, then should end in 1 because of 21. 3 to the power 5 ends in 3. 3 to the power 6 ends in 9. So 1, 3, 9, 7. 3 to the power 7. That's 1, 2, 3, 4, 5, 6, 7. So this ends in 7. And 3 to the power 8 ends in 1. So cycles of 4. 3, 9, 7, 1, 3, 9, 7, 1. So is the remainder 0? The remainder is 0 when the number is a multiple of the divisor. So for that case, you've been asked, is 3 to the power X plus 1 a multiple of 10? A multiple of 10 usually ends in 0, so we're dealing with the units number. So for that case, if you add 1 to each of these numbers, which one would have been a multiple of 10? If you add 2, 3, that's 4. To 9, that's 10. So this can be a multiple of 10. That is, if you have 3 squared plus 1, we'll have a number ending in 0. That means that will be a multiple of 10. If you add this will be 8, not possible. Plus this, that's true. So we only need cycles or bits whereby the number ends in 9. That's the second. So for that case, that's 3 squared plus 1, that will end in 0. That's a multiple. 3 to the power 6 plus 1, that will be also multiple. As you can see, we have 1, 2, 4 spots. So plus 4, that should be 3 to the power 10 plus 1. Yeah, 3 to the power 14 plus 1, and so on and so forth. Yeah, because if you do 9, 8, we'll have 9, 10, yeah, sure. So 3 squared, 3 to the power 6, 3 to the power 10, 3 to the power 14. And what is that pattern? Statement number 1, x equals to 4n plus 2, where n is a positive integer. Okay, that means x equals to 4n plus 2, that means 3 to the power 4n plus 2 plus 1. Is this a multiple of 10 when divided by 10? Or is this a multiple of 10 if n is a positive integer? Does this suffice this pattern? Of course, this you can say is more of, it comes with a pattern of arithmetic progression. If you're not familiar with arithmetic progression, please go ahead and watch the videos in the ISP channel. It's already covered. The first term is 2, and then you see the rest have multiples of 4 or in spacings of 4. So for that matter, if n is 0, then it should be 3 squared. If n is 1, then it should be 2 plus 4, which is 6. If n is 2, then you'll have 2 times 4, that's 8, plus 2, that's 10. As you can see, it's the same pattern. 2, 6, 10, 14. That's the pattern. So this is definitely sufficient. Yes, for each and every number, then it will be a multiple of 10. Okay, so this is sufficient. If statement 1 is sufficient, we don't have to combine the statements. So C and E are out. Then B is also out because it states that 1 is not sufficient. Okay, so let's determine if it's A or D. X is greater than 4. So if X is greater than 4, yes, suppose it's 5. Then the last digit will be 3. Yeah, plus 1, that will be a digit ending in 4. So that's not possible multiple of 10. But if X is 6, then it ends in 9. Then plus 1, that will be a number ending in 0. That means that this is a multiple. And this is not multiple. So for this case, for this one, no, it's not a multiple, doesn't have a remainder of 0. And for this, yes. So we have a no, we have a yes. We don't have a definite yes or definite no, or absolute yes or absolute no. Therefore, this is not sufficient. We say that the statement doesn't give us enough information for us to confidently say, yes, it's a multiple, or no, it's not a multiple. And for that case, D is out, and you have A as our answer.
You are watching Success with Bob Mwiti Show, presented to you by the International Scholars Program. The International Scholars Program is an award-winning international education financing scheme that helps bright students to pursue graduate studies abroad regardless of their financial background. You can find our programs by going to www.internationalscholarsprogram.com. The International Scholars Program, empowering dreams.
Let's go on to the next question and see if we perform well. So here's the question. Pause the video, give it a try. It also has the answer choices, and then I'll jump in. I hope you're all done. Let me write down the answer choices. So what is the remainder when the positive integer x is divided by 7? So this is a value question. Or you have what's the remainder when x is divided by 7. We need a unique value for us to prove sufficiency. So statement 1 states when 3x is divided by 7, there you have a quotient there, then you also have a remainder. That's one form of writing remainders. Or you can also write it as 3x equals to 7y plus, sorry, this is 1 over 7. Yeah, there we go. So we have 3x equals to 7y plus 1. So we need to find, let's find values that where x and y are integers. So we can have maybe 1 multiple of 3. We can have, if we say 2, 14, 15. If you say 7, that's 1, 8. So that's not a multiple of 8. So we can have when y equals to 2 and maybe y equals to 5. Yeah, such values. So let's try 2. So when y is equals to 2, then this will be 14 plus 1, which is 15, 3x. X will be 15 divided by 3, which is 5. So if x is 5, then 5 divided by 7, according to the question, will have a remainder of 5. Okay, what if when y is 3, what's 21, so 22, 4, that's 28, 29, that's 1 divided by 3, 5, that's 5, that's 6, yeah, that's possible. So we can have 3x plus 5 equals to 5 times 7 plus 1, which is 35, that's 6. So that 6 equals to 3x, so x would have been 12. If you divide 12 by 7, then you'll have a remainder of 5. You can see 6 will be 42, that's 43, 7 will be 49, 15 not possible, 8 will have been 56, 57. Yes, we can try 8. So for 8, we'll have also 3x equals to 8 times 7, which is 56 plus 1. That's 57. So x will have been 57. Divide by 3, which is a 3. 1 goes into this 1 because of 3. 27. This is, I believe, 19. Okay, so if you divide 19 by 7, this will be, I believe, 2. Yeah, 2 because of 14. And then we'll have a remainder of 5. So as you can see, there's a constant remainder of 5. Therefore, it's consistent and you have only one unique value for the remainder when x is divided by 7. Therefore, this is sufficient. If 1 is sufficient, we don't have to combine the statements, and B is also out. So you have to evaluate if A or D are the possible solutions. So let me raise the of A and D. We go on to the second statement. The remainder is 1 when 7x is divided by 3. So we have a quotient again plus 1 over 7 or 3 rather this time. So this is 7x equals to 3y plus 1. Let's find numbers that are x and y, or a set of x and y that are integers. So let's say we need to find a multiple of 7 for 3y plus 1, which will be, if you say 1, that will be 4, not possible. 2, that's 6, 7, yeah, so 2 is possible. So you can say y equals to 2. If y equals to 2, this is 6 plus 1, which is 7, and x will be 1. Yeah, this will be 7x equals to 6 plus 1, which is 7, so x will be 1. So if x equals to 1, then 1 divided by 7 will have a remainder of 1. Let's go to when y is equals to 2, this is remainder is 1. When y is equals to 3, then it will be 9 plus 1, which is 10, not possible. 4, 12 plus 1, 13, not possible. 5, that's 15 plus 1, that's 16, not possible. 6 will be 18 plus 1, 19, not possible. 7 will be 21 plus 1, which is 22, not possible 2. 8 will be 24, 25, not possible. 9 will be 9 times 3, that's 27, plus 1, 28. That's a multiple of 7. So we have, when y is equals to 9, then we have 7x equals to 3 times, we find the value for y first. So 7 times 9 plus 1, which is 27, 28. So 28 equals to 7x, x equals to 4. That's value for 4, for x. So if 4 is divided by 7, then you have a remainder of 4. So remainder of 1, remainder of 4, not consistent. Therefore, statement 2 is not sufficient again, just as previous question. And therefore, this is out. And our answer will be A. Hope that's clear. In case not, you can leave a comment. In case you're enjoying also the session, also leave a comment. And if you have a recommendation, let us know so that you can cover your topic for the next video. Let's go on to the last question of the day. Please pause the video, give it a try, and then we shall do it together. Okay, let me write down the answer choices. You understand we might be debating from Cyclicity, but also gathering something from all of this. So for this particular question, what is the remainder when the positive integer x is divided by 8? Another value question. We need one unique value for this remainder when x is divided by 8. Okay, so when x is divided by 12, the remainder is 5. So let's pick in some values. When x is divided by 12, the remainder is 5. So x, possible values for x can be 5, because 5 divided by 12, the remainder is 5. So the next possible value will be plus 12, that's 17. This is plus 12, should be 29. Plus 12, this is 1, 3, 41. Plus 12, this is 3, 53. Plus 12, this is 5 and a 6. Plus 12, a 7, and probably another 7. And at plus 12, this is 9, and this is 8. Plus 12, this is 1. So 8, 9, 10, 1, 1. Those are possible values, maybe to 100. So if you look at this, these are the possible values for x. What will be the remainder when x is divided by 8? If 5 divided by 8, then we'll have the remainder as 5. When you have 17 divided by 8, the remainder is 1 because of 16. So this is not sufficient. If it's not sufficient, then A and D are out. This is statement 1. For statement 2, when x is divided by 18, the remainder is 11. So the possible values for x will be then 11, because 11 divided by 18 is 11. The remainder is 11. Then you add 18 to that. So if you add 18 to this, this is 9, 29. 18 to this is 7, 47. 18 to this will be 5, 65. 18 to this is 3, 83. 18 to this is 1, 0, 1. 18 to this is 9, 1. Sorry, 18, there you go. 1 in 19, there you go. So these are possible values all to 118. So these are the possible values for x: 11, 29, 48, 47, 65, 83, 101, 118. You can confirm that too. Then you're asked the remainder of x divided by 8. So 11 divided by 8, we'll have a remainder of 3. But when you take 29 divided by 8, this is 24. So remainder is 5. So different remainders. And therefore, this is also not sufficient. We need one unique value. For that case, B is not the answer. Now we have to combine the statements. And I'll raise the slide for that. Okay, so let's combine the statements. If you combine the statements, then we have unique values. We have 29, 29, 65, 65, 101, 101. So let's try 29. 29 divided by 8. Did you try that? Yes, the remainder is 5. What about 65 divided by 8? 8 times 8 is 64. So this is remainder of 1. We still have different remainders. We don't have one unique remainder. And therefore, even when combined, the statements are still not sufficient. For that case, our answer will be E. Okay, we've started cyclicity and ended with remainders. I hope you got something out of today's session. That will bring us to the end of the session. If you enjoyed the session, please leave a like and make sure to subscribe to the content so that you expect better videos in the future. In case you have any recommendations, please leave that in the comment section, or let us know. We have our contacts listed in the description box. Otherwise, have a great day. Bye-bye.